all of you. On behalf of Confederation of Indian Industry, I welcome you to this technology webinar on operationalizing Internet of Things. CII in its mission to help Indian industry to become more competitive has been organizing webinars on various technical aspects of Indian requirements. Our speaker today, Mr. Permanent Chaudhary, Business Manager, Architecture and Software, Rockwell Automation India, has 24 years of extensive experience in industrial automation in varied roles. As a user of automation in manufacturing, project engineering in DCS systems, automation system marketing, and business management. Having experienced industrial automation as a user, as well as a designer, supplier, and marketer, Mr. Chaudhary possesses a thorough understanding of process control, operations, and energy optimization in manufacturing environments, ranging from process industries to discrete industries. A key member of Rockwell Automation core team that spearheads vision of the connected enterprise and manufacturing intelligence for our customers. Hope you will make most of your time with our speaker today, and by the end of session you will have all your questions answered. Over to Mr. Chaudhary, please.
Thank you, Priyanka. I think I will take over the presentation and show my screen. Just please confirm, Priyanka, if I am audible to you.
Yes, Mr. Chaudhary, you are audible enough, and we can also see your presentation.
Okay, thanks a lot. Good morning, and thanks everyone for joining. For many of you, it's the end of the month with certain commitments to be made for the month, so I can understand the need for managing time to join this call. I will straight away start off on the core subject of operationalizing the industrial Internet of Things, which to many of you may not be the first time that you are hearing it about industrial Internet of Things. Certainly, Internet of Things is something that is quite common these days. How industry, in particularly manufacturing industry, takes benefit of the technology like Internet of Things and moves to the domain of smart manufacturing is what we are all interested in, both from the standpoint of an automation company that which I represent, and as well as many of the manufacturers and equipment manufacturers as well as product manufacturers out there in this call who have taken time to join this. In the past webinars that we have conducted along with CII on this platform, we have actually shared these pieces of information in different ways actually. The market competitiveness, the dynamism that happens in the market, the limitations that we have with our workforce, with changing demographics, changing preferences of the nature of work that skilled people today want to take up, the changing nature of risks, and of course the ever-changing face of technology compels us and manufacturers to adopt these new technologies to work around the constraints that the market, workforce, and various forms of risks and security issues present today. So that's something that many of you are familiar with, and this is something, these are subjects that we have discussed in the past, so I will move on to more on the operationalizing side faster. Now, digitization has actually touched every aspect of our lives, as most of you realize, most of you experience on a day-to-day basis. And quite naturally, that digitization has found its way to the manufacturing environment to which, in which we perform day in, day out. 50 billion number of devices on the internet by 2020. I mean, that's a very, very amazing piece of statistics. Advancement made in the manufacturing environment in technologies deployed for manufacturing like robotics, artificial intelligence, machine learning systems that are able to predict failures and reduce downtime, sending out alerts all across, and very, very contemporary and commercial technologies like wearables and mobility that can change a whole the whole way that manufacturing practices indulge in today. Talking about wearables, very recently in one of my meetings with the leader of a large steel company in the country, I mean, they are actually a global company, I came to know that they are using wearable devices on their crane operators who actually walk up to cranes which are at very high levels, at very high elevations in their shops. And these wearables actually monitor the health, the blood pressure and other parameters of the body and report them back to their supervisors who are at the ground level. Now imagine such a simple way of deploying a wearable tool, but the kind of safety, the kind of comfort and safety in operations that it delivers. That's amazing. That's something that can be straight away benefiting the manufacturing enterprises. Talking about digitization, the first thing that comes to my mind is intelligent assets. Now, traditionally, the manufacturing companies in India have been using a lot of intelligent assets, and you are also familiar with them, many of you, most of you, in fact. These are typically the PLCs and the DCS that you see in your plants. Those small embedded controllers that come with various machines of different nature, of different technology, but they are all intelligent assets. They work with a lot of data that is arising out or emanating from the different machines that they are controlling. So on one hand, they control the machines, they provide the interoperability of between the machine and the operator, they perform the sequence of operations, they do process control, but at the same time, they gather a lot of data from the machines and the equipment that they are controlling. And that makes them very, very important in the scheme of the industrial Internet of Things. And with technology, what these equipment have additionally been doing, whether they're embedded controllers, sensors, PLCs, and DCS, is that they have been churning out a lot of diagnostics that tell the operators, that tell the supervisors, that tell the engineers in the plant of some impending failure, whether it's a failure of the device itself or a failure of an equipment or some deterioration in the equipment and so forth. So these intelligent assets that are self-aware are already out there in the plant. Many of you have been using them for actually decades. But what is changing is that these assets which have been self-aware for a while are now also becoming system-aware. More and more of these devices are getting connected to each other on a common network like Ethernet IP, Ethernet technology, which is a very, very prevalent, well understood technology today, tested over time, and that is extending to the manufacturing floor, connecting devices, intelligent assets together. And these devices, these smart devices out there in the field, are moving from being self-aware to being system-aware. They are more and more aware of their peers around them. They are more aware of the system in which they are part of. So they know of the security, the safety elements that govern all the devices, including themselves. They know when to download their configuration from which device and so forth. So they are more and more aware of their neighborhood, their surrounding, the network to which they are part of. Let's take a look at what smarter machines and equipment today in the shop floor can deliver. As I said before, they are churning out a lot of real-time data, and that's the key, the real-time data. As they are measuring, as they are controlling, as they are being measured, as being controlled through these smart devices like PLCs, DCSs, embedded controllers, and so forth, they churn out a lot of data. Simple data like electrical parameters of voltage, kilowatt hour, then other production-related parameters like runtime, throughput, other process-related parameters like temperature, pressure, flow, etc. Now, all these data are anyway getting recorded in the in the smart devices that are controlling these equipment. Now, when these pieces of data are seen against each other, seen in the context of each other, then relevant information around performance of the line or the machine or the equipment, relevant information about energy consumption per unit of the product produced, information around overall equipment efficiencies can be derived. So that's contextualization of the data leading to information that can be served to different people. For example, the maintenance people looking into the run hours, looking into the bearing heat signatures, and the production people looking into OEE, how the machines have been performing, and so forth. Now, when this information is run through analytics, that is where a wider knowledge is being gathered by the different roles within the in the plant floor. Ability to predict failures out of this knowledge, ability to point towards possible machine or equipment deteriorations, like some insulation failure, like some impending recharge of a catalyst that would be needed, and so forth. So deviations pointing towards deteriorations and failures provide that knowledge on which the plant personnel, the people working in the plant, can take appropriate action, take decisions based on their experience. And I'll give an example a little while away. So which helps them use their wisdom to optimize operations in the plant. So that's how the cycle of data works, from data being captured by smart assets and then transformed into information through contextualization, and then through analytics provide knowledge which allows the plant people to optimize their operations and employ their wisdom. So that's how it impacts the entire workflow. Looking at an example, this could be a typical food preparing, any food item manufacturing plant, which has noticed over the last 3 shifts that their batch time has increased. So that's the production people have noticed that their batch time has increased. The utilities, as they're being monitored by maintenance or utility engineers, have noticed that there has been a 15% increase in the energy usage. Whereas the instrument engineer or the instrument operator would have noticed that the time for the temperature in the oven to reach its set points has been longer than usual. While they may seem isolated pieces of information, they actually are correlated in some way or the other. Obviously, for any insulation damage that would have happened in the oven, or any heat loss that would have happened in the oven, the time to attain the set temperature would be longer, and consequently leading to a batch time increase. Similarly, because of the same reason, there would be an increased energy consumption. Now, when this all these information is aggregated and analyzed, the plant personnel would be in a position to take a call based on the supply chain requirements, based on the orders that they have to deliver. They can take a call on whether to shut down the plant right now and look into the oven insulation or the possible cause of heat loss, or probably run with this extended batch time for the next few batches, or one or two more shifts, and ensure that the entire production run is completed so that the supply chain is not impacted greatly. So, but they cannot indefinitely postpone it, because it is sooner or later going to impact the supply chain if batch times go on increasing. So it's a call that they have to take based on all this information and based on the wisdom they gather out of contextualization of this information and relating it to the supply chain needs of the plant. So that's a typical example of what information can do for a plant that has smart assets all across, giving them the data that transforms to necessary information and allowing them to run analytics and taking decisions. So there are, since the subject of today's discussion is primarily around operationalizing the Internet of Things, which or industrial Internet of Things, which are essentially the leveraging of the smart assets that are dotting the entire shop floor that you are part of. Now, there are many early adopters of this. People, manufacturing enterprises have leveraged the industrial Internet of Things. They have leveraged a smart manufacturing environment to get some definitive benefits through productivity improvement, through quality improvement, through increased uptime, reducing their manufacturing costs, and various ways. So these are just statistics to tell you about that, which is this is typically more of a North American statistics, because the survey carried out is by a North American database organization that maintains database of manufacturing enterprises, their financial and performance databases. So, but this gives an indicator that early adopters can straight away benefit, and there are various Indian examples as well as global examples to support this. Take an example of the well-known Mahindra vehicle manufacturing facility. They have tied their workstations to the supply chain and been able to send the master data back and forth bidirectionally to both sides to be able to monitor the variances, the different models that are being manufactured, and in the process of the free flow of information along the workstations and supply chain, they have been able to reduce, improve their error proofing, moving to zero defect delivery, reduce mean time to repair with alarms and real-time visibility, reduce the inventory on the assembly floor, and of course, in order to keep up with the changing demands, increase flexibility with in-process changes. So that's something that is a very Indian example out of a key vehicle making company in India. Looking at a global company which manages a number of oil wells spread over hundreds of miles and that are dotted with hundreds, if not thousands, of oil pumps in the open field, which is being governed by a cloud-based application that is monitoring, analyzing, and predicting the output of the overall field as well as individual wells, and then helping the organization to optimize their outputs based on the health of different wells. So it serves two purposes. One is that, as you can well imagine, that such a kind of a field or oil field, maintenance of individual pumps and wells is a very tall order. So the second thing is, because obviously you can't have every such well being monitored individually by people out there, so they have to be remotely monitored. And not only that, so as there is as the sensors and the controllers down at the well are actually sending back information on their outputs, on their diagnostics, their current state of operations, two things are being achieved. The monitoring team is able to identify wells that need immediate attention to prevent any impending seizure or failure of the well. That's from a maintenance point of view. The second thing that it does is, by monitoring the output of each individual well from the central location using the cloud-based application, they're able to predict their overall output of the field. So that's the benefit they get out of using these smart assets right down at the wells. Another example from a leading Indian aluminum major who actually make finished coils, aluminum coils. What they have done is they have been able to set up a system that allows their coil report, when deep dived into, provide the various processes that the coil has gone through and capture all the parameters, process parameters that the finished coil had experienced through its production process, and then compare it to the to what were their ideal coils or the golden batch that they had achieved in the past, and compare the parameters to predict the coil qualities between the current coil being manufactured and the typical perfect coil. So that's how they are able to track the quality of the coil that is being manufactured by comparing current data with historical data and making the golden batch comparison. Here is another example of an Indian, you can see the name, it's Jindal Steelworks out of Bellary in Karnataka, where they have actually been monitoring the flow and the calorific value of the gas that is generated in various shops like the blast furnace, the coke oven, the ladle furnace, and so forth. Now, by doing that, they are able to understand the energy that is being generated as waste out of these shops, which can be diverted to other energy needing shops where where energy or heat is needed to process the material. So they on a real-time basis, they're able to monitor and divert gas from one shop to the other in order to meet their energy requirements. So on a real-time basis, they're able to balance their energy demand as well as the energy that is getting generated through these gases from blast furnace, coke oven, and other furnaces. Now, these are things that they are able to do by doing online measurement and online analysis of the parameters of the gases, and thereby taking decisions on the fly. These are simple examples of what most companies have been trying to leverage the power of Internet of Things, the power of smart manufacturing in achieving their goals, which may not be an all-encompassing goal involving the entire enterprise, but some very specific objectives of energy, of defect reduction, of reduced downtime, and so forth. And finally, an example out of our own books, which is at Rockwell Automation itself. We embarked on this journey a few years back, and in course of our journey into the connected enterprise, what we have achieved is reduction of an inventory from 120 days to 82 days, reduction of lead times by 50%, reduction of quality PPM by 50%, and the other parameters that you are seeing, and the net productivity gain of 4 to 5% per year. So there are people out there, there are companies out there who are experiencing this, who are experiencing the benefits of this. So the question that we now need to ask ourselves, as many of the manufacturing companies embark on this journey or have the vision of leveraging the Internet of Things or industrial Internet of Things, is, are we ready, or are we ready to, and to what extent? Now, a simple survey again at a relatively matured manufacturing market like the North America revealed that only 11 to 12% of people, of manufacturers, actually had a strategy in place around IoT. Whether it is to build IoT in their processes or whether to build IoT into their products, about only 11 to 12% were actually having a strategy in place or implemented. Whereas about 1/3 of the respondents really had a plan to develop a strategy. So obviously there's a long way to go for each one of us, and despite having a evolution of smart assets in our facilities, how many of them are being leveraged to extract the information that gives direct business benefits to the organization? And that is what we are going to discuss today primarily. So what the digital transformation through industrial Internet of Things infrastructure has actually made a change to is in the way data and information movement has happened in the plant. Typically, a manufacturing setup would have been very layered or hierarchical. So for those of you who are part of the heavy industries or in some industries, terms like L0, L1, L2, L3, and L4 are quite common. These are level 0, level 1, level 2. Though the levels may differ in definition from industry to industry. But on the left-hand side, you see what used to be a very hierarchical movement of data or information. So the physical plant would have its data moved on to the process control or the machinery control systems, which would be the DCS and the PLC. These would move to layer 2, the supervisory control, which would actually work on generating the plant set point parameters or even optimization parameters. And then the supervisory control would send it up to level 3 and 4, which would be the manufacturing operations and business planning. So it would generally be very hierarchical. But with transparency of data, with more and more adoption of contemporary technologies like Ethernet, more and more assets being smart in themselves, more and more we being able to deploy more secured way of converging the Ethernet being used in the operations level and that used in the IT level, we have come to the hierarchical setup has given to a very transparent information flow between the shop floor and the information infrastructure. So there could still be some physical devices which are connected to PLCs and DCS systems, but most of these PLCs and DCS systems, whether they don't need really a supervisory system in between or a manufacturing operation system in between to converge on the information infrastructure. So information becomes free in availability beyond the process control systems. That's the change that the digital world in the manufacturing enterprise has brought in. That's one of the changes. And what has been responsible for that to happen is the convergence of information technology and operations technology. And this is perhaps been the greatest boon to industry, primarily because information technology has applied Ethernet technology for a long time. It has been tested. The security has evolved because very company confidential and intellectual property data resided on the IT network, so the concerns of safety had been very and security had been very high. So the security technologies have developed very fast on the IT side, whereas OT primarily has been very proprietary in nature and generally immune to such security threats. So we never really manufacturers gave a lot of thought to security at the OT level because they were proprietary in nature generally. But in trying to leverage the power of information as shop floor devices and equipment started generating more and more information on the real time, and that real information being of great value to manufacturers to be able to take decisions at the plant level itself, that needed a network architecture that resembled the IT architecture because A, the data has gone up, and B, as security concerns grew, it was probably easier to deploy security standards that were already used in the IT side of the world to bring them into the OT side. And this is a convergence that we are seeing rapidly happening all across all industries. So let's take a look at the 5-stage model for execution of the connected enterprise or smart manufacturing or leveraging the industrial Internet of Things. There are 5 key areas here, and most of them by their name itself, by the names themselves makes some sense to you already. Assessment, secure and upgrade, working data capital, analytics, and collaboration. This is what I would quickly go through in the next half hour or so for an understanding, and then we could exchange ideas. I could answer questions that you might have on how to deploy this execution model and what it takes to deploy this execution model in your manufacturing setups. On the assessment side, again, to give a brief background, 14% of manufacturers in the US have completely integrated plant floor. That's just 14% for a matured market like the US. 12% have no integration at all. 71% perceive their control system's threat level as moderate to severe, yet 24% have never performed a vulnerability assessment. So that's what the concern that could be in many of your minds as well around the need to establish to what degree are we exposed to security risks and any other risks for that matter. So an assessment to do to actually look into protection against security breaches, validate the network performance and reliability. That's important because you are getting all your plant floor devices, intelligent assets connected on a network, and if that network is not reliable, that can have a direct bearing on your network performance and thereby the plant performance. So validation of the network is very important. Data management, primarily arising out of the fact that traditionally manufacturing setups have seen different types of control systems being deployed for different purposes. Not only different makes, but also different nature of control systems, PLC at some place, DCS at some place, embedded controllers in some equipment, and so forth. Now these are disparate data sources involving disparate protocols and format of information which need reconciliation, and that's where the data management part of it comes from. And finally, to future-proof for expanded use and advancements in technology. So we all recognize that technology will keep changing. So what are those steps that you need to take to make your infrastructure future-proof? So that if you set up a network today, that network doesn't go obsolete tomorrow just because some technology change happened, some new protocol got generated for a very specific purpose. Or for that matter, most of the services now move to cloud. Most of the services are the front end of most services become mobile devices. Security technologies change, security concerns change. That should not turn your network infrastructure upside down. So how do you future-proof your infrastructure in the plant? So this is essentially the blueprint to having a connected enterprise assessment. So what we do offer is are a whole gamut of network and security services through our services team, through some of our partners, and this is primarily not an ad hoc equipment-based assessment, but a comprehensive assessment. Not that it tells you to turn your plant upside down and change everything, but it makes an assessment and gives you certain recommendation. And based on where you want to move, what are your immediate compulsions? Is energy your greatest concern today and that's what you want to address? Or is production quality the one that is of greatest importance to you today and you want to address it right away? Based on what you need, you can devise your solution. You can devise what changes you have to make. But the life cycle approach to making this assessment tells you, helps you identify the gray areas, the weak spots, and where you need to change, where you need to upgrade, so that you are able to realize your goal, whatever that goal be. So that's it's not about boiling the ocean. It's not about turning your current automation systems and your network systems upside down. The next stage is about secure and upgrade. And I have been referring to the word security quite a number of times for obvious reasons. We have seen security threats in industrial environment, and many of you recall, and there has been been so many incidents since, but primarily the eye opener was a Stuxnet virus that attacked a nuclear facility some years back in Iran. That was the first that I know is fresh on everybody's mind. But there have been various instances thereafter, and it's not just about securing from external threats, which could be someone trying to enter the company's network and fiddling with the manufacturing environment, but it could be even advertent or inadvertent threats coming from within. Disgruntled employees that could probably lead to some damage to a control system, or even inadvertent errors by individuals that could lead to a security hole, or that could lead to some disruptions. But it is interesting to see that organizations that have implemented smart manufacturing have seen improved efficiency in their operations and fewer defects in their products. So it's generally leads a secure and safe environment or infrastructure actually leads to higher efficiency and fewer defects. But threats will continue to evolve. Is your architecture ready to deal with it? That's what we need to. And all the readiness that you bring to your architecture cannot come at the cost of productivity or efficiency. So you have to be productive yet safe and secure. So some of the things that work when we are securing and upgrading automation networks is adopt a network technology which is common for both OT and IT, so that common policies can be applied to both the OT side and the IT side, and at the same time ensure there is a free flow of information, free but secure flow of information between IT and OT, because that's the need of the day. We are every manufacturer is interested in more and more real-time information out of the shop floors and port this information into their business systems, into their manufacturing operations systems, and make sure that real-time information is enabling greater flexibility, greater decision-making capability of the organization. So adopting a single unified network like Ethernet is probably the first step towards this direction. And then looking into the legacy systems that you have. Either you replace them or isolate them. Replacing always may not be an option for many of you because they are investments which have already gone into the plant and they have not lived their life, possible stated life yet. So you may not be able to replace everything that you have that is old technology, but how can you isolate them and yet get information out of them into your IT and OT systems? That has a bearing on the performance of the plant. Leveraging the data from these smarter devices and thereby reducing downtime to be able to have diagnostic and prognostic information from smarter devices and systems. And then very importantly, authenticate authorized and account for who has access and to what. So this is a very important thing that is increasingly of importance in a manufacturing flow. So securing the data flow all the way to the endpoints is the key thing here. That's what assets and plant can be protected by securing the data flow all the way to the endpoints wherever the data is needed. So one of the things that we offer is an integrated control and information platform. So the automation systems that we give as a solution to your plant needs are working on the fundamental of an integrated control and information platform. The control system basically has its own information part, which is basically visibility and some elements of operations management. But by and large, the core information platform that works on production optimization, that works on manufacturing intelligence, diagnostics and prognostics, and so forth, genealogy, tracking and tracing. This and the core control platform, they are part of a same integrated environment. This is a platform that provides secure real-time control and information. That's the elementary part of the control system design that we work to provide to you for any application, whether it is discrete application like a vehicle manufacturing plant or a process application like a power plant or a blast furnace and so forth. But what is important to understand that securing the automation and information system has a lot of elements. It is security is often, or more appropriately, industrial security is often confused with something like an external danger to the plant, just because we are moving to increasingly to an open Ethernet-based architecture in the plant floor, connecting devices on Ethernet. But that's just one small part of it. There are a lot of other things that need equal attention, like tamper detection, detect and record unwanted activity and modifications to various applications. Of course, securing the network infrastructure, which I mentioned before, controlling access to the network and detected unwanted access and activity. Segregating information that is time-critical, real-time information of control system versus information that is moving between different databases, which is transactional in nature. Even though they share the same network, how do you segregate the same so that one doesn't interfere with the other? Content protection and access control and policy management. These are all things that we have to work. So it is not just about how you contain any external virus from entering the system or an external threat that tries to overcome your firewall and get into the manufacturing floor. It's not just about that. It could be something as basic as how do I protect, how do I secure the program, the logic that is running inside a controller. So it is a system view. Industrial security has to be seen as a system. The third stage of execution of the connected enterprise or the industrial Internet of Things is big data. As we discussed before, the shop floor today is dotted with innumerable smart devices. These could be smart sensors, smart instrumentation, PLCs, DCS, and so forth. And they generate an enormous amount of data. Now, are we in a position to leverage this data, transform it into information that gives the ability to the manufacturing setup to be more versatile, to be more flexible, to be more quick in their decision making? Interestingly, when we talk of big data, or people like Microsoft and all the people in the IT world talk of big data, you would be surprised that the amount of data, big data that manufacturing churns up is higher than any other sector, notably the services sector. That's 2 exabytes of data. And this information is probably a bit old, about a year old. So I'm sure the current world sees much higher amount of data out of manufacturing. So that's the key. You have a lot of smart equipment, smart assets in your plant. Are you leveraging the data that all of them are generating? Are you leveraging that to your benefit and using it as a competitive advantage? So what it is all about, it is about delivering actionable information in real time to all the stakeholders in that manufacturing setup, and share this information, share this data across multiple operations, multiple functions within the enterprise securely, without having to worry about any security issues. That's the key. So that is unleashing the value of standard data from devices in and around operations and leveraging them for addressing all the challenges that operations face today or that a manufacturing enterprise faces today. Visualization, of course, comes as a very important part of the managing the working data capital, or all the data that is appearing out of your manufacturing assets. So mobility being a very contemporary technology that is being put to use very regularly in manufacturing setup today. In fact, the same company that I mentioned about having put wearable devices on their crane operators to monitor their health, the same company is talking about having their maintenance and supervisors and production supervisors being able to see the data that they're interested in, whether it's production data or maintenance data, on their mobile devices. That's what is the vision out of the managing director of the company. And finally, the fourth stage being analytics, which actually transforms that information into knowledge that allows the people, the personnel in the plant, to derive direct operational benefits, to understand on a real-time basis their operational efficiencies, the overall equipment efficiencies, their energy cost per ton or per unit of product produced, the impact of raw material on end products, the different batches of raw material, tracing back a finished product to its raw material, and so forth. Various operational benefits that allow people to change, to be agile in their decision-making processes, and thereby making their manufacturing processes more agile. So what is it about operational benefit realization? It is to understand process performance in real time, the ability to respond quickly to changes in the process. So if you have noticed a change in the process, you are able to take a quick decision on either as I gave you an example early on, the decision for that food manufacturing line was to, the decision that they had to make was to take a call on whether to stop the plant now, correct the problem on the oven, the heat leakage on the oven, or continue with the run for the next 2 shifts so that the supply chain remains undisturbed. And that's the kind of decisions that more and more people on the shop floor would be taking because of the ability to derive analytics as we have been discussing. And decision making is on the plant floor is enabled by the fact that information is made available to different people based on their roles. So contextualized role-based information leading to right information going to the right person at the right time. So whether he is an executive in the company or a production management performance personnel in the site, or an operator on a line, based on the information that is required for him or her in that organization, based on the role, the information would be made available to them and they would be able to take the right decision. And that's what analytics support, empowering people to make smarter and more informed decisions. And of course, notification. As I gave an example of how a leading steel manufacturer is thinking of deploying mobile devices, trying to get alerts out of their operations, production, as well as maintenance to the relevant people on their mobile devices, whether those be tablets or mobile phones. Notification on the fly, notification to the person who is the key stakeholder in that operation is very important. know when and what that needs attention. And finally, collaboration. Now, this is probably a very interesting part, and this is where all that we discussed before about analytics, about data capital, all that we spoke about before has a bearing on the amount of collaboration potential that the shop floor can, or the manufacturing setup gets exposed to because of the Internet of Things. The moment knowledge is available in the form of contextualized role-based information, different people within the organization can collaborate. Not only different people within the organization, it could be between different organizations, between the supplier and the user. For example, if as a manufacturer you are using equipment that comes to you from different OEMs, you can collaborate with your OEMs around the performance of your machine. Not only the production people and the maintenance people and the quality people collaborating with each other, but people from within the organization collaborating with someone outside who is part of the supply chain. So what that leads to, amongst others, is improved inventory by managing your supply chain, right parts being there at the right time, at the right place, knowing your performance parameters better, knowing how much of material you're using, labor and energy you're using, and thereby controlling your budget, and remote access to people, assets, and data in real time in a secured manner. And we'll talk about remote access a little bit more in the following slides. As I mentioned in the past, that more and more assets are getting smarter. So there could be a possibility of collaborating between different shops in a plant, even though they may be operating independently. They're performing the, let's say, a blast furnace and the coke oven in a steel plant for that matter, or a coal washery, whatever that be. Different shops, but they could still collaborate amongst each other and make sure that the supply chain that happens between them is undisturbed, even if there is an operational issue at any one of them. And that is possible through these remote services, through the remote connectivity. So it helps in remote monitoring of assets, their health. The oil well example that I gave you at the beginning. It helps in the production management, knowing what equipment is running at what throughput and what is the expected production out of it, and various other benefits. One thing that is very interesting could be a collaboration between the manufacturer and who is making the finished good, and the machine builder who has made the different machines for this manufacturing setup. So here is an example. It is it's an example that we have derived out of a current exercise that we are doing with one plant manufacturer currently, who makes equipment and equipment, machinery, and plants for the food and beverage industry. We are working with them to establish a remote services architecture, something of this nature, which connects to different plant sites using some of the contemporary technologies that technology leader like Cisco has developed, which is the GRE or MGRE technology, which is related to dynamic multi-point virtual private network, which allows the OEM to connect to different sites where his machines are functioning at his customer's place, and monitoring them not only for maintenance purposes, but also collecting performance data to improve his own design in future. So this helps in commissioning of this information. So if of this equipment or plant, which is maybe thousands of miles away from the equipment manufacturer, it could be to study the equipment to derive information, performance characteristics, or even take operation and maintenance services, offer them to the end user, and thereby monitoring the health of the equipment and advising the end user on pending failures or deterioration and corrective steps that need to be taken. This can also be used in training, as I said, preventive maintenance, and of course parts management to help the user build inventory of spare parts that would be optimize on the inventory of spare parts that would be needed to service their equipment when they are approaching failure or when they break down. So this is one classic example of collaboration, not beyond something that we were talking about between the personnel of a plant, but this is beyond that. This is between a supplier and its of a machine and the user of the machine. So on that note, I would just want to conclude my discussion point on something very interesting that we in Rockwell Automation are trying to have very recently launched, and you will hear from us more on this in in the coming weeks and months. This is a collaborative environment, very much like a social networking environment of what we are all very familiar of, like a WhatsApp, for example, where different personnel within a plant can actually share resources and be part of a group to exchange information, and that helps both from the point of production, operations, and maintenance. It is something as simple as a group of people sharing on their mobile devices, sharing information, exchanging information, and whoever is a recipient of the information and whoever is the expert on that subject would be able to exchange ideas, advise people on corrective actions, and so forth. There could be team boards, there could be incident reporting, there could be chats between different people, and also connectivity to the knowledge base to actually look into possible remedies to know the faults that they're seeing on the plant. And this is all possible through the mobile handheld devices like iPhones or any Android-based phones. So stay tuned for more on this subject. This is a recently launched service, and currently it is available as a free download, particularly for users who have subscribed to our Tech Connect services. And very soon there would be multiple improvements to it and additional features that would be brought in and finally taken into our cloud infrastructure. So we will come back to you more on that. You'll hear those who have been using Rockwell for a while will hear from us more on this very soon. And this is something that you could think of enhancing the collaboration, a way of enhancing the collaboration within your personnel in the plant. So with that, I come to the end of my discussion, and before I open this out for questions, I would like you to leave this discussion with the following understanding. I took you through the 5-step process of executing the connected enterprise or smart manufacturing or industrial Internet of Things, leveraging that. It starts with assessment, then moves to the secure and upgrade, thereby going into creating an infrastructure that leads to leveraging the working data capital coming out of all your smart assets in the plant, moving on to analytics, and finally creating a collaborative environment towards managing the operations on the shop floor. So what you need to understand is that it needs at an organization level, it needs an adoption of a culture that needs to adopt contemporary technologies, focus on safety, security, industrial security, and not limit that thought on security to just about threats from outside that can work its way into the organization or into the plant floor, but threats that can come from anywhere, that can come from wrong usage, abuse, or incorrect use of hardware and software. Technology upgrade and modernization is a very key part of it. But again, as I said in the past, that you really don't have to turn your plant upside down. You can identify your objectives, whether it's energy, whether it is quality, whether it is track and trace. What is the problem that is troubling you the most today? What is that is keeping you awake at night? That could be your place to establish this kind of an architecture and an environment first, and then extend it to other parts of the plant. Training and education is a key part to it, of course, because there's a lot of contemporary technology being used. There's a change of workforce that is likely to happen, that is happening currently. Change of demographics. More and more people wanting to do different kind of jobs. And very key in this is at the bottom two words, partnerships and change management. Anything that has to do with collaboration has to happen with partnership. I gave an example of how the manufacturing setup can partner with its suppliers. And that was the OEM user kind of partnership that I spoke about. And change management, because this needs a lot of thought leadership and new technology to be adopted. So a lot of change management has to be in place in order to maximize the benefits of industrial Internet of Things. So that brings me to the end of my presentation part of it. I would like to now make it open to questions. So let me just sorry, I am just trying to locate here. Mr. Rao or Priyanka, if you are on the line, can you just tell me how do I make the questions pane open?
Mr. Chaudhary, can you see the chat window?
Yeah.
Yeah, you have to drag that window and read the questions. There's a plus sign over the chat window. Just press that and then expand that window.
Okay. Okay. It shows grayed out right now.
So there are no messages there?
Yeah, I just had one message which was a comment. That was Mr. Kokate. Are there any questions? I think, yeah, you can, send in your questions on the questions pane.
Would request all the participants to type in their questions at the chat window so that Mr. Chaudhary can read these and answer.
Or would it be okay to actually open the audio lines for people to ask questions if they wanted to?
Mr. Chaudhary, I'm afraid that won't be possible. People have to, type in their questions and then only we can answer.
Okay. Can you just type in, Priyanka, some question just to see that it's working? And I'm not sure if people are. Of course, I got that comment from Mr. Kokate, but I'm not sure if others have been trying or not. Yeah, I'm seeing your comment, yes. So okay, I do have a few which I'm trying to look at. Okay, so I have a question, Priyanka, that is from. Let me look at this question. Who is it from? Again, the question is from Mr. Kokate, and the question is, how can a non-IT engineer configure dashboards? Now, that's a good question, Kokate Saab. The answer is actually on two things. One is related to what exactly you want. So, if a dashboard is something that that is designed based on what is it that you want to monitor and track. For example, a dashboard can be a simple dashboard of the production on an hourly basis, and it could also be something of the runtime of the machine, the uptime of the machine, and so forth. So number one is what is that parameter that you want to monitor, and you want to and to what detail you want to monitor. Is it something that you want to see it in a red-green band that it is bad or good? So you can design your dashboard in that way, or it could be a little bit more detailed in the graphical form and so forth. Now, for a non-IT person, for an operations person, when we deliver the manufacturing intelligence solution through our Vantage Point software, that is one of the means of doing it. The software has the ability to connect to all the production or the shop or the machine tags directly and provide a plant model. Okay, so even though there can be some pre-delivered dashboard from our side based on whatever discussion we have, and we give you some dashboards, you as an user would be able to make ad hoc dashboards based on anything new that you want to see tomorrow. For example, if I have given you a dashboard that shows the production at every shift, and but you want to actually have a dashboard to see whether the temperature of a particular section of equipment is within its tolerance band or not, and how it is performing across around its set point. You want to see a view of that. You could design a dashboard in an ad hoc basis yourself. You can just drag and drop the tag or the parameter that you want to measure. That could be a temperature parameter. Drag and drop that in the dashboard builder, and quickly set up a simple dashboard in front of you. So that ad hoc, on an ad hoc basis, you would be able to do that. That is the power of the Vantage Point system that it offers you, and it is to the user. It is all left to the user to design the dashboard. So the dashboard builder helps you build those on the fly. This is because it already has the model of the plant or the equipment built in, and all the tags or the parameters that are part of the model are there for you to leverage. So it's for you to design anything that you want in the future. So there's another question from Mr. Kashi Vishwanathan. This is about what are the inbuilt analytics or data models that you have. So the answer to that is this is very industry specific. So we have certain specific industries like automotive, food and beverage, tire, and a few others for life sciences. Some of these dashboards or even analytics have already commonly used analytics and dashboard. Some of these models are, of course, very intellectual property of the users, but some of the commonly used analytics are available as free to use when you buy a system for us. That may or may not serve your purpose that is for you to decide. But if you want any improvement on that, that can be built in as part of the project. That can be built as part of the project. So you could probably use that for your off the shelf, or you could modify it and use it. Once the plant model or the equipment model is built within the analytics tool, then everything else is left to your imagination. You could build any kind of a dashboard or analytics view. Could be trends, could be red, green, yellow kind of dashboards, could be slightly complex bar graphs and so forth. But it is all left to you on how you want to improve on it further. So one more question. This is from Mr. Avinash Srivastava. The question is, do you have any sensors and components which have IoT-based technology? We do have sensors and components that are moving into IoT-based technology, in the sense that they would be compatible directly to the to a network like Ethernet IP, and have that information extracted on the network itself. Now, traditionally, discrete devices like light curtains, presence sensors, and things like that, because they deal with a very small amount of data, it has not been commercially viable to build Ethernet ports into them. But as these are becoming more and more part of a larger system, where you are monitoring not just the health of this device, but multiple other devices, and technology being more affordable, we are building these more and more into the devices, and more devices are coming up with the Ethernet IP connection port built on them. So that's one part to answer one part of your answer to the question you had. The other thing is that even and it does not depend on whether we have a component or a device or a sensor which is Ethernet enabled or not. Any device out of today, there are mass flow meters, there are process instrumentation that are coming more and more coming with Ethernet ports on them to make them directly sit on an Ethernet network and exchange information over that Ethernet network. That is evolving, and more instruments are coming up on Ethernet. So while these have been traditionally on very specific field buses, more and more of these instruments today are coming on Ethernet IP. Mr. Ravi Kumar, I just noticed your comment also. Thanks for that. I will, to answer your question, yes, your question, let me read it out for the benefit of everyone. Will you support us in identifying smart solutions in field as per our requirements? Yes, the key thing is your requirement. Once you have a goal set for yourself, we can work together to see what it needs to change in the field, or what it needs to, if at all, a change is needed or modification is needed. What would that be to help you attain your goal, to get the information that you want in the way to help you take some business decisions, or get some business benefit out of that endeavor. So we would be definitely honored to work with you on that, And that's exactly the message I was trying to drive in the execution model. So Mr. Kokate had another question which I will let me read it out. How close a PLC engineer will be able to configure as like SCADA? Now that's a good point. I mean it is the trend today that people tend to work on joining blocks rather than going into creating everything from scratch, writing every control scheme or every interlocking scheme from scratch. People actually want to join blocks together, and that is what is the future. That is where it is going to. Some of the DCSs have been using this for a while. This is to be a very common thing in process control. We have been doing that in process control also for a while. But for machines, for equipment and machines, this has not been that prevalent. But given today's situation, in the way machines have to be turned around in a very short span of time, the way you have difficulty in accessing or hiring talent, it's imperative that PLC logic or machine logic also be built from libraries, standard libraries, and these blocks are just dragged and dropped into a configuration and interconnected rather than having to write logic from scratch. So that's something that is very much in the evolution right now, Mr. Kokate, and I'm not sure, I know some of my colleagues visit you, but we could in one of our visits explain to you how those libraries can be used in a drag and drop method. So there is a question from Mr. Kasi Vishwanathan again, probably a follow-up to his earlier question. How much do you see these analytic models generic for a given industry or unit operation? So I will just answer that question. So these models are can be both generic and sometimes very specific to the industries. As I said, that as more and more experience come out of deploying these solutions, there are some standard needs that are already identified for certain industries, for most industries in fact, and those models are already available, pre-configured or pre-built. So there's not much of work to be done to build those models really. But how you want to use those models is what is important, and that is where, as I said, it's your imagination, whatever you want to do, how you can use that model to deliver that. But yes, there are certain things very specific to the industries. There are certain things quite generic, like energy is, I would say, largely generic. But things like quality, production, and information out of that, and models around them are very specific to industries. So there's a mix of both. So I think I have a follow-up question from Mr. Ravi Kumar again. Okay, that was asking me whether I can view his questions. Yes, I can now view the questions. So Mr. Vishal Vaswani had a question around how does IoT help in change management? IoT per se does not actually you know, drive change or help in change management, but change management is a natural fallout of embracing IoT, and particularly in the industrial field. In the commercial field, I mean, in our day-to-day lives, you know, IoT and things, technologies like that have become kind of compulsory. You probably, there's a day a day would come when you won't be able to book a cab with the phone by calling. You have to use the app and call, you know, get that cab in. You know, you cannot order a particular product by visiting a retail shop, and you would be forced to actually use the contemporary technologies on using the apps and selecting your product. So IoT essentially will lead to the need to have change management. What I meant by change management was not change management as in an engineering term, but a change management from the point of view of how do you embrace and deploy technology, and what changes you have to make in the way you work today to embrace the technologies of IoT. That's what I meant. So change management essentially is something you have to drive in the organization to actually embrace IoT or smart manufacturing. So Mr. Kashi Vishwanathan had a question on what is your expectation on the effectiveness of predictive analytics. So that my answer would be the predictive analytics have been there for a while. I mean, it's not something that is very new. The difference being that to carry out predictive analytics in the past would have been a very arduous task, because the very task of getting the right information or data to carry out the analytics would be a very difficult one. And the reason again for that being you know, non-standard protocols, very proprietary protocols and network architecture and things like that. And more importantly, once you develop an analytics model, to make a change to it would be an enormous task, because you would have to now fetch additional information. So you add another equipment to your plant, and if you have to bring that equipment into that same model, the amount of engineering activity that you would have to do would be again enormous. So you know, just you know, to fetch the additional information. So to your question, the effectiveness of predictive analytics is very high, particularly in complex processes in manufacturing, where you have to kind of estimate the final outcome of your manufacturing line based on what you are inputting in, based on ingredients, based on process parameters, based on maybe the dwell times in reactors and so forth. So it ultimately is the ability to predict what the outcome would be, outcome of a certain set of events or incidents be. That is what is more important. And in certain situations, when you have when you don't have recourse to direct measurement of certain parameters, some of them have to be sensed in a non-contact or a non-direct measurement way using soft sensing, you know, that kind of a thing, where a set of measured parameters tell you what another parameter would be. So based on that, so it is ultimately something to do with modeling. But predictive analytics have always been effective in complex processes, and in certain processes you have to do it. And in processes where it is not really imperative, IoT can help you get some additional mileage, get some additional benefit out of using predictive analytics. So if you have a plant, you know, if an equipment that is running and based and something as simple as based on the vibration pattern of the equipment, it is able to tell you that it is going towards a failure 3 days hence. That's a tremendous input for you. I'm giving you a simple example from a maintenance point of view. It gives you a tremendous benefit because now you can actually plan your production and the upkeep of the machine in a way that has minimum impact on your final output. So that's an example of predictive analysis. Vibration signatures being a very, very simple example. It could be a whole lot of parameters. It could be even being able to tell you that the current supplier of your raw material has had a change of grade, and that is going to spoil your upcoming production. It could be something as critical as that also. So Kajal Ghosh had a question which was, do you have a checklist for making an old plant IoT enabled? Yes, I think it is not as straightforward and simple as a checklist, but yes, something close to it. We can. It starts off making an assessment. We could help you, in fact, make an assessment yourself, and then you can call it a checklist or a guideline or whatever. It is a consult. We can consult you. You can consult us. We can discuss together, and you can make some basic checks on your existing setup yourself, and then take a call. Or you can invite us to do that for you. So I think this question from Mr. Parshwad Vora. The question is, which is perfect architecture with safety? Direct connection of field instruments to a network to PLC, or field instrument to PLC to the network. So either way. So if you are, it doesn't matter actually. The consideration of having field instruments connected to a PLC, and then the PLC or the control system, working on the control philosophy, or the system itself, the field instruments using their own intelligence executing control philosophy, either way is okay so long as your purpose is met. From the point of view of IoT or IIoT, it's not really that much of a difference, because you can achieve the same with both kind of an system configuration. There can be other considerations on why you want to do why you want to have the field instruments themselves doing the control philosophy, executing the control philosophy, rather than the PLC or the DCS. Those are different considerations, but from the standpoint of IIoT, it really doesn't make a difference. Okay, so the question from Mr. Anand Dikshit is, does Rockwell Automation provide a IIoT platform on cloud? Yes, currently we use the Microsoft Azure platform to provide that. In fact, the oil well example that I showed to you, that was based on Microsoft Azure, and that was executed by Rockwell. And very soon we will also be with our own cloud platform. And that would be an extension of the kind of solutions that we are providing today. So Mr. Kashi Vishwanathan had another question on which manufacturing industry is predominantly focusing on IIoT today, IoT transformation in India and US geographies. Well, I showed examples out of automotive, oil and gas, yeah, and heavy engineering like steel and aluminum metals, that is. But you do see them in almost all industries today. And the drivers or the imperatives are sometimes different. You know, the oil and gas example that I showed you was more to manage remote assets, which are difficult to otherwise manage because of their location spread around thousands of acres. Uh, so the driver for that was different. There are other drivers, like if you look into the life sciences industry, which is very, very strongly regulated, and even the food industry, which are very regulated industries, they need to be aware of their entire equipment status as the product is being processed, and they need to have records that are tamper-proof and easy to maintain and very comprehensive at the same time. So the drivers are different. So we are seeing adoption because of across industries. Some have been leaders in that, some have been following, but today as we speak, most of the industries have adopted this very strongly, or either adopted this or have plans of adopting this. And as I showed some examples, some of them have been adopting this in pieces. For example, the example on energy management, that could be an area of concern for an industry, and naturally they would try to tackle that concern first and work on these technologies to get the benefit of better energy management capabilities. There was another question. I think Kashi Vishwanathan has left. He had a question, but I'll reserve that for later. This question was from Vibhav Mehta, whether firmware changes are needed in PLC DCS to leverage these technology of, or convergence of OT and IT so that information is seamlessly available. Yeah, sometimes it may involve firmware changes, but more importantly is the adoption of the network technology. The network needs to be standard Ethernet-based network, because that's the most suitable network for information. So, and most proven network for information. So it is important that we have a standard Ethernet-based network infrastructure in place, and the devices should be updated to at least support that. So normally, if it is already using a proprietary network, moving it into Ethernet cannot be done through a firmware change, of course, but probably would need an upgrade of a section of the hardware or introduction of a Ethernet gateway to extract the information and port it onto Ethernet. So I think Mr. Pramod Kokote had a comment that I think we discussed this before about making the PLC programmable by common electrical engineers or even without having too much of specialization in logic programming and things like that, and being able to use standard blocks of the library and connect them together based on the operations philosophy of the equipment. So Mr. Suresh Krishna had this question about, can a non-IT professional work in the area of IoT? What extra knowledge required for a non-IT personnel? I think this is very much in our day-to-day life. Every person is using IoT almost in some way or the other, or experiencing IoT in some way or the other. Of course, knowledge about contemporary technologies like Ethernet, security, it depends on the role again. If he's an engineer designing system, then the level of knowledge needs to be more deeper with respect to security and infrastructure. But for users, I think users have already started using different equipment in their daily lives that leverage IoT. So I think it's not much of a great training that is needed, but it's definitely a change in the way we work. We generally work in the manufacturing floor that needs to change. So I have a very interesting question from Ms. Aarti Karkare. I think she has left, but this would be interesting for most of you. Is about as a service consultant, what is a strategy one should tell their customers on legacy system migration to new integrated platforms? Now, this is very important because it is again tied to the need of the user. If the user is wanting some specific goal, is wanting to achieve some specific goals, that could be of better energy management, that could be better productivity, or better quality. It depends on that. It is tied to the goal of the user, and it should not be thrust upon the user to upgrade their technology when probably there is no need of it. But what benefits that new technology would bring to the user, if that is clearly laid out and if that ties well with the objective of the customer, that is the approach that service providers should take. So Priyanka, while I'm going through some of the questions which some of the participants who posed those questions have left, so I'm not going through them, but there's a request that if we can consolidate all the questions from the window and probably send the answers which have not been already answered to the people who have asked those questions, that would be useful.
Sure, sir, that can be done. So I suppose this is the end of the webinar.
Yeah, I see most of the questions coming from people who have left already, so I think we could collect the questions and then respond.
Sure, sir, we can do that. On behalf of CII and Mr. Chaudhary, I would like to thank all the participants for joining us for this technology webinar today. And Mr. Chaudhary would also like to thank you for this valuable session and your inputs. Lastly, wishing everyone a happy and prosperous new year. Stay connected for more such webinars. The presentation will be emailed to all the participants. Thank you.
Thank you, Priyanka.